And before going into the examples, you should know the basic information like steric number is the one which is used to find out the hybridization, and steric number is nothing but number of sigma bonds and number of localized lone pairs on that central atom. And based upon the steric number, we can give hybridization and geometry of the molecule. That means if we know the steric number, we will come to know what is the hybridization of the molecule and what is the geometry. Okay, now let's go to PCl5 molecule. In PCl5 molecule, the central atom is phosphorus. So take phosphorus, and phosphorus belongs to 15th group element. Its valence electrons are 5. So take 5 electrons here. And chlorine is the surrounding atom, and it is monovalent. So put single bond with each chlorine atom like this. Now count how many sigma bonds are present. 1, 2, 3, 4, 5. 5 sigma bonds are present. So steric number will become 5. Therefore, hybridization will be sp3d. Very easy. Second example, let us see. SO3 molecule, sulfur is the central atom. Take sulfur, and sulfur 6 valence electrons, 1, 2, 3, 4, 5, 6. And oxygen is a divalent atom, so put a double bond with each oxygen. And then count number of sigma bonds, 1, 2, 3. Therefore, steric number will be 3. If steric number is 3, then what is the hybridization? sp2. And we should know the table so that by steric number, you come to know what is the hybridization, and also you will come to know what is the geometry. In this case, in sp2 hybridization, geometry is trigonal planar. And next, in COCl2, the central atom is carbon. Carbon has 4 valence electrons, 1, 2, 3, 4. Different surrounding atoms are there. Chlorines are monovalent, and oxygen is divalent. So put oxygen with a double bond and each chlorine with a single bond. Number of sigma bonds, 1, 2, 3. So steric number will be 3. Therefore, hybridization is sp2. Geometry is trigonal planar. Next, SOCl2 molecule. In SOCl2 molecule, central atom is sulfur, and it has 6 valence electrons, 2, 3, 4, 5, 6 valence electrons. Oxygen put a double bond O, each chlorine single bond, as they are monovalent atoms, and 2 electrons are left over. These 2 electrons, you pair them into a lone pair. Okay, now steric number is number of sigma bonds plus number of localized lone pairs. So number of sigma bonds, 1, 2, 3, and 1 lone pair is there. Total 4. Steric number is equal to 3 plus 1, that is 4. So steric number 4 means hybridization sp3. Got it? The next HCl4 molecule. Xenon is a central atom. Take xenon. 8 valence electrons it has. 3, 4, 5, 6, 7, 8 valence electrons. Fluorine is monovalent. So put single bond with each fluorine. And 2 electrons make it into 1 lone pair. This also another lone pair. Now, number of sigma bonds, 1, 2, 3, 4, and lone pairs 1, 2. So steric number is equal to 4 plus 2, that is 6. So steric number 6 means hybridization is sp3d2. sp3d2. The next, HCOF4. Xenon is a central atom. So you take xenon and 8 valence electrons, 4, 5, 6, 7, 8. Oxygen is a divalent, so put a double bond, and 4 fluorines are there with the single bonds, 3, 4. Then remaining 2 electrons into 1 lone pair. So now to calculate number of sigma bonds, 1, 2, 3, 4, 5, and 1 lone pair is present. So steric number is equal to 5 sigma bonds plus 1 lone pair, total 6. Therefore, sp3d2 hybridization. Next, ammonium ion. Nitrogen is a central atom. Now this is the cation. ammonium ion. So nitrogen is a central atom. So nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. So remove this electron. If you remove this electron, then what will happen? Because of one positive charge, you are removing one electron. And 4 hydrogens are there. Hydrogen is monovalent. So put single bond with each hydrogen atom. So total, how many sigma bonds it is? 1, 2, 3, 4. Steric number is equal to 4. Therefore, sp3 hybridization. Then coming to anion. Sulfur is a central atom. So it has 6 valence electrons. Put 6 valence electrons. 1, 2, 3, 4, 5, 6. And 2 negative charges are there. Therefore, put 2 negative charges. These are for due to the presence of negative charge. Then 4 oxygens are there, and oxygens are divalent. So put double bond with each oxygen atom. And now count number of sigma bonds. 1, 2, 3, 4. Steric number is equal to 4. Therefore, hybridization is sp3. Then last example, xenon is a central atom. Take xenon. This is called perxenate ion. Okay. So xenon 8 valence electrons, 2, 3, 4, 5, 6, 7, 8. Then 4 negative charges are there. So add 4 more electrons, 2, 3, 4. Now these are because of the negative charge. These 4 are extra electrons are because of the negative charge. Now 6 oxygens are there, and oxygens are divalent. Put double bond O with each oxygen. Double bond O, double bond O, double bond O, double bond O. Now count number of sigma bonds. 1, 2, 3, 4, 5, 6. So steric number is equal to 6. Therefore, sp3d2 hybridization. This is the trick.